This
whole
conference will now be recorded.
realm is two things. You need to be willing to invest a lot of time, and you need to have great organization skills. And when you are able and willing to invest a lot of time and structure your program and structure your team, then you're going to start seeing a lot of success. And that's exactly what we've had. That's what we've been able to do the last several years. It's what we attribute to, the excellence awards that we've won at state and the world championship excellence in 2019. It's all because we've invested time and we've had structure and organization. And so that's kind of one of the first things that we do I'm in the midst of camp right now, which is why I'm wearing the shirt. We have 2 weeks of summer camp. 180 kids are at our camp, which is just incredible. And what I just got done telling them today is that one of the very first practices that you will have, you and your coaches and your teammates are going to discuss team structure, putting kids in places that are going to help your team succeed. And those are just, different sub teams and different roles on the team, just like a football team would have, just like a basketball team would have. It's having that structure. And then, of course, you need to think about your season timeline, not just diving right into your first practice and building, but really kind of thinking about what the timeline of your season looks like. And so you need to digest the rules. Every year, the rules change. And so your kids need to understand those rules even better than you. And Adam and I put out a video. It's like an hour and a half long. Feel free to watch that, or have your kids watch that. Just going through the manual and the rule book. Your kids need to understand the rules first and foremost. Once they understand what they're allowed to do and not allowed to do, then you start formulating and discussing different strategies. And once you have a strategy, you let then your strategy guide your design. And that's how you start building from there. I'll never forget, I had a coach one time ask, and it wasn't a dumb question, but they just asked, hey, last year's game pitching in, can we just build our robot to do a low hang and then at the start of the match drive to the bar and hang? I was like, I mean, yeah, you're capable of doing that, but that's not a great strategy that's going to score you a lot of points. And so you need to kind of really just map out your season there. So, Adam, feel free to jump in. I know that was a lot.
No, you're right on point with a lot of that. And one of the things that's great about having Jake here, especially with me, is that Jake's crazy in that he puts lots of kids on a team, and I don't know how to do that. So, like, if I were to ask a question, it's like literally, how do you do that? Because we've tried doing roles in the past, and maybe we're just not disciplined enough to make sure that they have all of the things that they need to do mapped out for them. But how do you actually go about doing that with your
That's what
different
it
sub
is,
teams?
Adam. You're just not disciplined enough. That's what it
Yeah.
is. No. I'm kidding. This last year, I'll tell you this, I think VEX recommends like 2 to 4 kids or 2 to 5 kids per team. And in our district, we tried to, at the very least, put 6 kids per team. Last year, I had 9 kids per team, and I'm going to be honest with you, that's way too many kids, and it felt like too many kids. And there were times definitely where there was downtime for kids, and then anytime you have downtime, you have messing around, and then you're not using you're not using your time the best that you possibly can. Time on task is definitely your biggest advantage in robotics. You think about private teams or private organizations, which is awesome. The biggest advantage they have is they have as much time as they want in their basements or in their lofts or whatever. And for our program, we only have about 4 hours each week of practice time. And so we practice Tuesdays and Thursdays after school till about 4:45 ish. But on top of that, we also have build parties, extra time that we build. Christmas break, if the kids who don't leave or go anywhere, they come in and have build parties and build sessions. And so it's just this time thing. And so yeah, for me, I have a couple different assistants, and we have our sub teams. We have our build and design team number 1, which is 2 kids. And then we have our build and design team number 2, which is 2 other kids. And I'll talk about those two and the differences in a second. Then we have our programmers, we have our documentation kids, and we have supply managers. And so every kid has their role, and we have on our board different objectives that we want them to accomplish that day. And then obviously the goal is for them, if they complete their objectives for that day, then they then dive into the other sub team roles as well. And so I think that's what it is just having a pulse on your team and knowing exactly where they're at, and then providing objectives, daily objectives for them to tackle each practice. If you don't have stuff for them to do, it's going to be chaos, and it's going to be even harder for you. And like we talk about all the time, this is a student-centered organization. And we are the ones that organize everything, and then we provide the opportunities for the kids. And it's amazing because it is always so exhausting at the very beginning of the season, especially at the elementary level when you have a lot of new kids each year, and you're training them and teaching them about their sub team roles and what their priorities are and things like that. But then as the season goes on, my job becomes easier and easier because they just tackle their roles, and they've bought into their roles, and they can do it all pretty much independently at that point. So I think it's just, having the discipline to create those objectives and having the pulse on their team, on your team, to know what their next goals are. And of course, you're not the one always setting those goals for them either. Before long, they're the ones creating their own objectives and creating their own goals, because they tend to know what they need to work on for the next practice more than we do anyway. And so it's just getting them to that point of independence, and then your job just becomes a facilitator and an organizer, and helping them problem solve when they become, when they get to places that are too difficult for them. Does that answer your question, Adam?
It starts to, for sure.
I would not recommend 9 kids, by the way. I think 5 is pretty sweet.
And I have several 2-person teams. I've got, let's see, of my 4 teams, 3 of them are 2-person teams. One is a 3-person team that might go to 4 later on. And that's just because of the dynamics of those teams and how they ended up wanting to work together. It is also a way that 2 of the teams were actually one team previously, that I ended up splitting into 2 teams so that they could have more hands-on time and be able to learn some of the aspects that they wouldn't necessarily be able to have direct experience with if they were on a larger team.
Yeah, and part of the reason that I take so many, and that my coaches take so many on their teams, is because we have such a high interest in our district. It's robotics is just completely taken off in Wani, and which is pretty crazy because we're an Amish community, and we're a very small rural school, less than 3,000 total K-12, and so the reason that we make our team so big is we already have to make cuts. We already have a selection process where we try out and have applications, and that's hard. Like it's hard to cut kids. You don't want to cut kids. You want to give every kid the opportunity, which is why I run these summer camps, so that every kid can have that opportunity. But for our competitive teams, we still have to make cuts. On any given year, I might have, just at Woodview, 40 to 60 kids try out, and if I'm running 2 teams or 3 teams, that means I'm only going to take 6 kids out of all those kids. And so I'm trying to take as many as I can that makes it still to a point where I'm not going to burn out as a coach, because that's really important too. And because I've seen that. I've had coaching friends who did it for 1 year, maybe 2 years. They ran 8 teams by themselves, had 8 kids per team. And it's like, dude, you have 64 kids that you're running, and you don't have any assistance or help or anything. No wonder you hate this. You're completely burnt out. And so that's why I said at the beginning, coming up with structure and organization within your team, having head coaches, having parent volunteers, having sub teams, and things like that will make your life so much easier. What else do we have out there? I think I can talk about the Build and Design 1 and Build and Design 2. I think I mentioned that a little bit ago. Those are just 2 of our sub teams that we have. And I learned this idea actually from Adam. We call it the Leapfrog Strategy. And that I've had that implemented for the last 2 or 3 seasons, I think. And man, I'm telling you right now, that's been a huge life changer for our program as well, because we talk about this concept of rebuilding. I don't want to rebuild every year. I want to reload every single year. And especially at the elementary level, where I'm getting fourth and fifth graders, I'm going to have new kids every single year. And that's exhausting to have to reteach all the stuff that you just taught last year. So instead of rebuilding, I'm going to reload. And so that's where the build and design team 1 and build and design team 2 comes into play, because my build and design team 1 is now my fifth graders, my experienced kids who've been a part of the program for over a year now. They've become incredible builders. They understand that process, the engineering design process. The build and design team 2 are usually, for me, fourth graders, new kids to the program. They've probably been to the camps for a couple years, but they don't have a ton of building experience. And what they do is they attach themselves to my build and design team 1, and they learn from them. So that takes a lot of pressure off of me and a lot of time off of my plate, because they're learning from the fifth grade kids. The fifth graders are mentoring our younger kids. And then you just have that continuous cycle from year to year. So this next year, I have incoming fifth graders who were part of Build and Design Team 2 last year. They're at the camp right now, and they are just absolutely crushing the competition at the camp, because they've had so many learning experiences from these older kids on the team. And so what they're doing during the season is they are building a replica robot of what Build and Design Team 1 is building. They're building the exact same thing. They're looking at the Build and Design Team 1's robot, and they're building piece by piece, step by step, the exact same thing. And so that's teaching them different concepts that the fifth graders are coming up with on their own. The fourth graders are then learning from that. And then also there's a dual purpose to it. The second great thing about it is that it then eventually provides us two robots, right? We can't compete with two robots. We can't take both robots to a competition, but they're identical. And then one robot can be driven, practice driving. The other robot can be programmed. And then when you're still in your build phase, the leapfrog strategy, what I was referring to earlier, is one robot can be being driven by the drivers, while the other robot is then being modified and improved. And then you take that robot, they drive it, they bring the other robot over, build that up, and then they keep leapfrogging back and forth to continuously improve your design. And also, like I said, time is your biggest advantage. Your drivers aren't wasting any time or losing any time. Your programmers aren't losing any time either, because you have that extra robot. That's been really instrumental for our program. What are the ways that we can constantly find more time without actually being here in the robotics room spending more time? What else do we have? Jamie, you don't have any questions? You're over there in Vegas, just living the dream.
I don't know about that. I haven't hit it rich yet. Let's see.
Hey, Rich has a question if you don't have one.
Go ahead.
Do you try to have every student learn programming and every student try to do some of the mechanical build stuff?
Yeah, so like I said, we have our sub teams. So kids kind of specialize in certain areas, but every kid is a part of all the process. So that's when we debrief at the end. Every kid's a part of that. When it comes to programming, we do have a lead programmer, but then we have optional programming practices where anybody and everybody is welcome to come. Some kids have zero interest in it, so they don't come. It makes your practices a little bit smaller. But generally, like last year, out of 18 kids that I had, I would probably have 13 show up to those optional programming practices. And yeah, everybody was a part of that process. It wasn't just one kid on the computer and nobody else knew it. Because for me, when it gets to the interviewing process, we want every kid to be able to speak about every part of the process. And that happened to us back in 2019 when we ended up winning the world championship. They said a couple things. They said, if you Every team at Worlds is going to get 1 interview. If you want excellence at state, you're going to get 2 interviews. If they really like you, you're going to get 3 interviews. And we ended up getting 8 interviews that day, or that World Championship. And I loved that. I love standing back. Obviously, I'm not a part of the interviews, but I love standing back and watching, because what they did is they literally, by the time we got to like 6th, 7th, 8th interview, they would just flat out point to a specific kid and ask him a question. They would say, hey, Lily, talk about the process it took to build this mechanism right here. And she was able to speak on it. Even though she wasn't build and design team number 1 or whatever, she was able to speak on it because she was still part of that process. So yeah, like the kids do specialize in specific things, but I imagine it being like a quarterback knowing, all the wide receiver routes, or the offensive line knowing which holes to block because of the running backs, where the running back's going to go. So every kid is a part of all the process. And that's really on you as the coach to make the kids aware and to make sure that you're pulling them from their specific sub team and having them help with other sub teams in different areas. And that's a little bit easier to do when you have teams of 2 or 3. The kids kind of have to do all that
Yep.
stuff. So.
Yep. With my teams, I end up splitting it up usually, unless there's one of the kids is really strong and the other one just really has no interest. But usually I will have them swap back and forth, and they will learn all of it together. But yeah, with 2 kids, 3 kids, it's super easy to do that with them.
Your programming program, what do you use for that? I mean, is it online, or is it something that has to be on a computer, a laptop?
So the current officially supported most popular is called VEX Code IQ. So there is an installable app that you can put on Windows, Mac, or Chromebook. There is also a web version that is codeiq.vex.com. In my experience, there is a little bit of a difference between the two. So I haven't checked in the last couple weeks, but with codeiq.vex.com, there's currently a bug in it that does not exist in the standalone versions. So your mileage may vary on that. However, the web-based version loads way faster. I'm like the installed app will take like 30, 45 seconds to start up. The web app, the web page version is almost instant. So if you're trying to just get in and do something quickly, it works really well. Actually, I can just show you. So this is codeiq.vex.com. Mine, I guess I would have to probably make this a little bit smaller so that it fits on the screen a little bit better. Oh, not do it that way.
How do we make you large so we can see you?
At the top, you can change your view everyone to view speaker.
Ah, very good. Thank you.
And then when I'm speaking, you can, let's see. If I don't know why this is not wanting to behave for me today. Well, maybe it'd be easier if I just did an actual share. Jamie would have to let me do that, I think. But while I'm talking about
Adam,
this,
before you go too deep into that, we could save that for the programming hour.
yeah, I just wanted to like be able to show the app, but that's okay. So there are those 2 options. Those are, let me actually get my face back up here. Those are not necessarily the best options. They may be for what you're doing. One of the things that it allows you to do is to teach kids with blocks. But kids are able to learn this in a lot of different ways. So one of the other options is one of the apps that we used to use, Robot C. Now it's not, and Daniel, you can talk to this more than I can, but is it still like getting support? I mean, I know it still works, but like, how does it interact with like the Gen 2 brains? We cannot hear you, or at least I cannot.
Can you guys hear me?
Yes, can now.
Okay, all right, perfect. Yeah, because I guess you guys couldn't hear me earlier. Yeah, so basically Robot C doesn't, it's no longer supported for, Gen 2 brain. If your team is mixed with both Gen 2 and Gen 1, and then your best bet would be VEX code, right? For IQ, for VRC, I don't know. I see Joel there, your high school teacher, I guess. You may run VRC team, and then your choices would be VEX code for V5, right? Then there's a pro version, right? Slightly more advanced, right? And then you can also use pros. That's a third party and done by Purdue University. So you have multiple choices over there. But going further on what Adam was saying earlier regarding the web version, you have to keep in mind when you actually go to competition, you may not have internet, right? It really depends on where you go, right? Then that version may not work in that case, right? So keep that in mind.
Jake, do
Looks
you want
like
to answer the question in the chat? And then,
Yeah.
or I can't tell. I think it's just the question in the chat. I don't see any other hands raised unless I miss someone. Make sure you.
Yep.
Oh, Rich, is your hand still up? Or okay, I'll lower that.
There you go.
So yeah, I think we're just ready for the question in the chat, Jake.
Okay. So the question in the chat says this, Mike's not working. How do you treat your teams differently between elementary and middle school? So I'll answer that one first. Several years ago, I guess a few years ago, the REC Foundation released what's called the student-centered policy. And there's an actual document that outlines the student-centered policy. And it goes from green to yellow to red. Red being danger, danger, do not touch this area. And it gives examples for everything. It goes from, programming examples, mechanic examples, interview examples, engineering notebook examples of what you as an adult should not be doing. That's the red danger zone. And then it considers the yellow and the green as being acceptable things for you as the coach to do that would make it considered student-centered. And so at the elementary level, what I tell my coaches is that since these are young kids and new kids who are not born engineers, just like the manual literally says that, kids are not born engineers. And so there needs to be adult guidance. Yep, just attach the student-centered policy in the chat there. And so what I tell my elementary coaches is, this is a learning experience and opportunity for your kids who have really no experience doing robotics. And so I want you to kind of focus your coaching strategy to be right down there in the yellow portion of the student-centered policy, which they say is acceptable and completely fine. And so what that looks like is more of a you as the teacher guiding them. I'll never forget, I had a coach one time tell me, you know what, I just want the kids to just explore on their own. I provide all the parts and they just explore on their own, which is totally fine if they have a foundation, right? But these kids did not have a foundation. So these kids exploring on their own with no adult interaction and no teaching, no coaching, didn't produce any results. And I used the analogy, she was a math teacher. And I just said, You're a math teacher. Do you just give your students a bunch of numbers and then let them explore with those numbers, or do you teach them and coach them? And so one of those things is, and we're doing this at camp right now, is like on the mechanical side of things, is showing them different prototypes. So me building a simple, very, very simple prototype that wouldn't even probably work by just attaching it to a robot, showing them this prototype, showing them that concept, and then letting their own gears, change in their minds. And so that's the difference that I use between elementary and middle school, because then with middle school, they've had a couple years of robotics experience and they've hopefully learned through that elementary experience. And now you're getting into the green section of the student-centered policy, which is really just release. And so, we spend more time coaching and teaching at the elementary level, less time at the middle school level. And don't get me wrong, don't mishear me. I'm not saying that my coaches at the middle school just sit back and grade papers the whole time. They're still very involved and invested as well, but it's a lot more independent, just like you would expect, in any learning environment. Team size, we kind of talked about that earlier. They recommend 2 to 5. I have 6 to 9 per team. It's probably too many, but it has worked for us. As long as you have specific roles and tasks for the kids to work on, you could have as many as you want, but they recommend 2 to 5. I feel like at the elementary level, it's nice to have more. And then at the middle school level, you can kind of trim it down a little bit. Perfect example, we have 3 kids on our documentation sub team. And at the middle school, really 1 kid or 2 kids can do that. Everybody contributes, but they're kind of the main ones there. What do you do from a tryout application process that you find effective? Okay. So I hit on this a little bit earlier, but not much. That's just been kind of a process for me too. As we've gotten more and more popular in our district, kids want to be on the team, and I have anywhere from 40 to 60 kids try out just for my own 2 teams. In our district, it's several hundred. And so we have to trim it down. We just don't have enough time, money, resources, coaches to accommodate everybody. And that stinks. That's the worst part about it. And you got to make that clear up front when you have your first parent meeting of any interested kid. Like, listen, I don't enjoy doing this. This is the worst part of the season, but I do not have enough time, money, coaches, resources to take everybody. And so with that, we have an application and tryout process in our district. And so what that looks like at that first initial parent meeting, you have to come to the meeting with your parent. That's kind of the first trim, right? And at that meeting, you're going to learn about what robotics is. I'm going to talk for 30 to 45 minutes about what the season looks like and the expectations and things like that. And then when you leave, you're going to pick up an application. And I made several years ago, 7 years ago, I made I think it's a 6 or 7 page application, pretty intensive, especially for elementary, but I did that on purpose. Because if you're not willing to put in the time to fill out a 6 or 7 page application, then chances are you're not willing to put in the time to do a 7, 8, 9 month, robotics season. And so, so that's the next trimming piece, is filling out an application. They have 2 weeks to fill that out. I used to do they needed to get a recommendation letter, but once my kids got up into the middle school, I started getting like 18 requests to write recommendation letters, and I hated that, so I cut that out of my own program. And so then I have a tryout. So if you have submitted an application and you still want to try out, then I have 3 days of tryouts, and during those tryouts I have 3 stations. I have a build station, I have a drive station, and I have a documentation station. And so that just, I think it says, especially in finding good notebook takers, as part of the question. So I have a documentation tryout station. And so what I've done is I lay out all of our previous engineering notebooks on a table. I give them, 5 minutes to kind of peruse through them. And then I have created a sort of made up scenario for them. Last year, I don't even remember what it was, but basically your team has this idea to attach a certain thing to their robot. And so it's just basically, here's a full page of graphing paper for you to include, parts and steps and problems and solutions and sketches. And so what I'm looking for is their organization. I'm looking for handwriting, although that's not a huge factor for me. I'm just looking to see like what everything looks like on their end as far as documentation, or are they just writing a full on 5-page thesis? And so I just kind of look through those, and I look for just artists and good writers and people who are organized and things like that. So and then after that, I have all these spreadsheets with data collection based on the scores that I've given for documentation, based on their driving tryouts, based on their building tryouts, based on creativity and things like that. And then I just kind of rank them, and so that's why I do those types of tryouts, because I don't necessarily need 16 to 18 amazing builders on my team, right? Like I had a boy on my team last year who hated building, and he did horrible at driving, but his documentation tryout was the most beautiful thing I've ever seen, and it was incredible. And so I put him on the team. His name was Braden, and I'm still convinced to this day that's exactly why they won the state excellence award and why they won the design award at Worlds, because of his notebook and his team's notebook. So hopefully that answers your question, Jason. If not, then feel free to say more in the chat. Looks like there's a couple other things in the chat now. Money signs, yeah, it's expensive. What fundraising ideas does everyone have? Ooh, that has been kind of the fun part of my director job. I thought I would hate that, but I've really enjoyed the fundraising side. I don't know. I could talk all day about fundraising, but my favorite thing that we do is called the state tune-up. And so we schedule it the Saturday before the state championship. And it's kind of like a walkathon. You guys know what a walkathon is, or like a swimathon or whatever, where you get pledges for however many laps you walk or whatever. Like, I'll give you $1 for every lap, and you walk 100 laps and they give you $100. So we do the same thing with the state tune-up. We open up the gymnasium for all of our district teams. We put a bunch of fields in the gymnasium. We open the doors at 9 a.m. and we close them at 9 p.m. And kids can get pledges from family members or neighbors or whoever on the number of hours that they're going to work to fine-tune their robot before the state championship. And so that means, working on building it, working on programming. That's a big one right before state. Strategy and driving and things like that. And so then they just keep track of their hours. I give them a little certificate. They take that certificate and show it to the people who pledged money, and then they collect money. And I think we raised about $11,000 doing that last year. We had a big community dinner where we just presented about robotics, and we called it the Gearing Up event. We sold tables anywhere from $300 to $1,000. And we also had a silent auction, an online auction, different raffles, 50-50, that sort of stuff. And we raised $34,000 for that. What else? Yeah, I mean, we do a lot of things like that. We raised about $92,000 last year for our district robotics teams. And that was the main reason, was because we took 10 teams to the World Championship. We needed 2 charter buses. Charter buses are like anywhere from $15,000 to $20,000 for one. We needed hotel blocks. We needed catered meals. And so we needed to raise quite a bit of money. So fundraising is definitely a big part of why we have what we have and the success that we've had. Writing grants as well for your community foundation. That's a big one. They're always willing to give money for stuff like this.
I would add a little bit to that. Just ask.
Yeah.
A lot of businesses, like, really all you have to do is ask, find the right person to ask, have something specific and have something tangible. But there's a lot of people, like, depending on where you're at, obviously, but there are a lot of individuals and a lot of businesses that are very interested in helping out, especially once they learn what it is. And the other one that's potentially a big one, depending on what your capabilities are, but hosting events. Hosting an event can actually be a halfway decent fundraiser. Like, you're not going to pull in necessarily $15,000, $20,000 from it, but registration fees for all the teams, if it's large enough, like you can get a couple thousand pretty easily. And then if you've got food options that are on, you can essentially do revenue sharing with food companies, food trucks. You can have concession stands. There's been a couple of teams that I've seen that when they host, they have different people in the community like actually build and make things to sell there. So we actually bought at one of the competitions, we bought a couple of different robotic signs that we could put up as decorations. So there's lots of those options. Like a lot of it is really just being creative and being willing to get out there and ask
Yeah.
for it.
Yeah, you just need to ask. It has to, if you work for a school, it has to obviously be board approved and superintendent approved. One of the other things I forgot to mention was, and Jamie mentioned this in the chat there, was t-shirt sponsorships. And so we sell logo space on the back of our competitive jerseys, and I think it was like over 15,000. We had a ton. We have different levels, right? We have like the gold, the silver, the bronze, platinum levels where you can spend more money. We'll put your business logo on a banner that we display in our pits, and really just asking for money. All of these companies want to offload money to schools and nonprofits because of the tax purposes. So we have different levels for that too. I think 1,000 is our highest one. Something I think I'm going to do this year. We have a really nice Facebook page that has over 1,000 people that follow and a lot of engagements. And I think one of the options will be we'll put your logo on like our Facebook banner at the top of the page, and that's free advertising for you for a month or whatever. I know Daniel over there and up in Canada some logo space on our jerseys and put his own team logo on our jerseys. So that was pretty cool. It was like 70, 80 kids walking around Dallas, Texas from Wani Robotics with the caution tape robotics logo on the back. So just ask. There's a lot of people want to support this program, and you have to be very specific about what this program needs. People don't realize how expensive it can be. And so we have on our sponsorship sheet, we have kind of like our budget, how much kits cost, how much competitions cost, how much jerseys cost, how much worlds cost. That's the big cost right there. And so it's a good question. A lot of fundraising. I just be creative. ABC Fundraising is a really cool website that has really unique fundraising ideas. We've tried the Spinner fundraiser. They have like scratch off lottery ticket fundraisers, which I think are really cool. We've never done that, but that would be pretty neat, I think. Looks like Nikki has her hand raised.
Hi. I was wondering if you had recommendations for like teaching the engineering notebook and how to do that. I always struggle to find like good examples online, and then just with limited time, it always did not turn out as I would have hoped it to.
Yeah, that's a great question. The first thing I would do is pull up the rubric. The REC Foundation has a rubric of what the judges are supposed to follow. And I don't know, Jamie, if you want to post that rubric in the chat there. But that's what we do every single year. We print the rubric out and we give it to our documentation kids. And obviously we look at the columns that score the most points, right? And so there's a bunch of different categories in those columns and what it means to be expert in that specific category. And so I would start with that. That's definitely the first 1 or 2 practices, is going over that rubric with your kids and making sure they really understand the process there. And then I don't know if there are too many like actual examples online. I know my kids made a video a couple years ago of tips on an engineering notebook, YouTube video. I don't know, Jamie, if you want to find that too. I thought that was cute and helpful because they kind of go through each of those parts of the rubric as well. And then I don't know how to share it on here. Let me see if I can actually I'll pull up mine let me see if I can find it. I don't know if this link will work, but I'm going to try to attach it. Let's see. Let me click that link and see if that pulls up. That would be last year's red team, the Woodview Eaglebots red team engineering notebook. Does that work?
Yep.
Sweet. So there you go. There's an example, and that was a notebook that helped win state excellence in design at Worlds. So that's one of our best ones. Braden Dale, the kid I was telling you about. Check that out. It's amazing. It is absolutely amazing. So the main thing, and we talked about this at camp this morning, the main thing with the engineering notebook is it's not like a scrapbook of your team. Like you're not taking a picture of Susie and Johnny and then writing a caption underneath saying, this is Susie and Johnny driving, and then putting another picture of, Tommy and John building. Like it's not a scrapbook or a team manual or whatever. It's an engineering notebook, and the focus is on the engineering design process, where you began and the process that you took to get all the way to the end. And you're going to see in that example, you're going to see how we started with rules and scoring, and then we went into strategies, and then we let those strategies then guide our designs and our builds. And you can see at the bottom, chronological order, October 7th or whatever, they start building, and you can see just, the robot in its infancy. And then as the season goes on, the dates go on chronologically, and you can see that the robot is getting better and more complex and more effective. And throughout the process, there were a lot of problems that they documented, solutions that they came up with, parts and steps, and just different design ideas and why they chose this idea over this idea and things like that. So I
Because part of the whole engineering design notebook, as what Jake has said, is all about engineering design process, right? I don't know, the coaches here, what your background is, assuming, most of you guys are teachers, right? Not engineers, like what Melvin and I, where we come from, right? So I think the first thing you need to have your students to learn, before they even document anything, right? It's about engineering design process. There's actually a video I can post, made by, somebody, I guess, some organizations, right? It's a very fun, video talking about engineering design process, right? And then you can use that video and teach the students about the whole process itself. If you look at the whole process from beginning to end, it's always very, very similar. Doesn't matter, you see them as 9 steps, 5 steps, 6 steps, right? All comes from starting from problem identifications, specify requirements, right? Brainstorming ideas, evaluating your, solutions, right? And then doing some testing, and then you're gonna have your result, right? Your whole season, your whole engineering design notebook will be basically a lot of small components and following engineering design process again and again and again, right? Do not think about as a whole thing. I have to do it for just entire robot for the entire season. No, it's not like that, right? Say for example, let's say this is I don't know you guys, but we have already because we're a private club, we have already kick-started our season. And then the first thing, when we talk to the kids is, okay, let's do a quick game analysis, right? What would be the most important thing for you guys to do, right? And then everybody says, I want to shoot pucks, into the 4-point zone or whatever, that point zone is. Okay, so now everybody thinks we need to make some kind of shooter. So you already narrowed it down from just basically building one robot to just one shooter, right? And then when you have a shooter, then you already identified your problem, right? So think about it this way. Now you have your problem. Now the next question is, what would be your requirements, right? And then because if you ask the students, they will say, hey, I want to build a good shooter. It's like, that does not work for me because as engineer, right? Because part of your requirements will help you to know whether your prototype or whatever you have implemented works or not. Because if you tell me I need to build a good shooter, that means, okay, what if I shoot one puck within 1 minute to shoot it into the 4-point zone? Do you think that's a good shooter? The kids will think, no, that's not good. Okay, now we're talking, right? And now you tell me, how many do you expect to shoot within a minute? Or 30 seconds, 10 seconds? Now they start thinking, okay, let's think about it. Maybe 5 to 10, right? Like 10 pucks within 30 seconds. I think that's good enough to start. Does not matter, whether it's, that meets your standard or not, right? Because, different club, different school have different standards, right? Because, some of our top teams are always aiming for maximum score, right? Like last year, I had one team can actually score, 20 balls within skills run, right? So their requirement would be different than the beginner teams, I just want to shoot 6. Right? So with that requirements, and then you can work with the kids. Now, okay, let's talk about what ideas do you have, right? They may come up with 3, 4 ideas, and then, okay, let's document them down in the engineering design notebook, right? And then there goes your picture time. Okay, this is how they do it. If you want to go into further details, you can even list the items they have used to implement that, right? And then the final part, okay, let's evaluate what we have done, right? And then are they good enough? Do they pass our requirements we defined earlier? If yes, then let's close this whole iteration, right? And then let's review it. So bottom line is, when my kids asking me, hey, Daniel, do you think my engineering notebook is good enough or not, right? The first question I ask them, do you think it follows the engineering design process? Do you have all the steps, the engineering design process should have, right? Where's your problem? Where are the requirements? What ideas did you come up with, right? That's the first question, right? And number 2 would be, if you pass your notebook, let's say Jimmy did the notebook and you pass to Lily, do you think Lily can build the same thing as you have done? Basically, repeat your work. If the answer is no, and then you could still work on your notebook, improve it a little bit, right? So that would be, it sounds very simple, but it's a very hard job to do, right? Do not make it too hard. Do not make so much strict rules about it, right? Because their learning is a process. And I also want to bring some good news for the coaches. At RECF EP Summit, Bob, who's the CTO of VEX Robotics, I think Pascal posted that news in the Facebook group. Basically, RECF has done, or not RECF, VEX has created a template, a Google Doc template for the VRC team already. They're going to share that template to everybody, and then, any team can use that Google Doc template to create your own engineering design notebook. And the beauty of that is it has all the VRC components in it, like, the beams, the gears, this and that. And then their target release date for VexIQ would be end of August. Because it's basically their, a graphic design team is still working on to create all the, the components, the parts, right? Because VexIQ has way more parts than VRC. Because, there's no modification in IQ. Right? Sorry, Jake, I jumped in,
No, that was great, man. That was great. Somebody asked about the digital versus physical in the chat there, and you already nailed that.
Yeah,
It's weird because
it's
go
actually
ahead.
a topic in the RECF EP Summit, the digital and the physical. Yeah.
Yeah.
So
I like
like
the physical.
I
I
think
was gonna say
the
I like the
new trend, we got from RECF Summit, it's like official code, right? It's not my words, it's basically what RECF is saying. Or like Bob actually made a presentation about it. Before, they were thinking, the notebook should be, bonded, that very traditional way. But no longer the case, right? They are embracing the changes, right? They also find, we're in the digital world, and then kids are more comfortable with all the digital format. They're on Discord, whether you like it or not, right? So they're on Roblox every day. So the key thing is then RECF is saying the digital format is staying. The world interview will be the same format as we had last season, right? Basically going to be a hybrid. So which means you have to submit your digital version, regardless, right? Whether you actually did a physical copy or not, right? You have to scan it and you submit it, right? But local qualifiers, whatever you want to do.
I think Jamie has her hand raised for a question.
Yes, I had a couple of questions. My first one is we have both Gen 2 and Gen 1 brains. Our district has just announced that for our district league, they're only going to allow Gen 1 brains because not everybody has the Gen 2. In fact, I think my school is the only one in our district that has the Gen 2 brains. Can somebody talk to me about how those are different? And my thought was managing that by having two robots that are pretty much identical, except one is the Gen 2 and one is the Gen 1. We use the Gen 1s for the district league. We use the Gen 2s for other competitions because we have, I would get, better coding capability using the gyro, but I don't know a ton about it. So I would love your perspective on that.
Okay. If we want to talk about the difference between Gen 2 and Gen 1, number one, for sure, Gen 2 does have, built-in, or internal inertial sensor, right? Being the inertial sensor means that 3 axes. The gyro you can get from Gen 1 is only 1 axis, right? Which means, it only detects rotation, right? Well, it depends on the direction you're putting it. Basically, the inertial sensor is, like 3 gyro sensors in one, and it's already built into the brain itself, right? So it definitely saves you a port or maybe 3, right? Depends on what you do. And then, from the coding perspective, yeah, like what Mark was saying in the chat, Gen 2 does support Python, right? Which Gen 1 does not, right? Gen 1 does only support C++, right? I don't want to go into too much technical details about it, but, from capability wise, I do not see the decision your district is putting in is fair, right? Number one, being Gen 1 is already discontinued, right? Everybody understands, the struggle for everybody to get a Gen 2 right now. Because I ordered my Gen 2 back in March and I just got it last week, right? So, there's basically right now, if you order now, there's going to be 3 months delay. But to be honest, going into the competition, then your only advantage you actually have on Gen 2 is I'm using inertial sensor, and the other robot is using a gyro sensor. And to be honest, unless you are the top 1% of the team, in the world that you are shooting, the top skills, like I'm in the top 3, top 10. It does not make any difference to you at all, right? Like whatsoever. So
I'd like to add that the sensors and the battery might be a big difference for the district, because the V2 battery is lithium ion, and then the sensors there's new optical sensor, new distance sensor. The V1 distance sensor is basically obsolete. The second one's much better. So a few hardware changes.
Yeah.
And I'm not really sure they're allowed to kind of ban that from your league, right? Like, is that I don't think that's okay for them to do.
That would be competition legal.
Well, that's good information for me to take back and ask about that then. I think it comes from trying to keep a level playing field. We have 11 elementaries. We have very different programs in each of those elementaries. And I think because my team I spent a chunk of change and went ahead and got the Gen 2s last year. I think there are some feelings about that. So I think
It's
that's where
not
that's coming from.
it's not going to give you this gigantic competitive edge over any other
No,
team. And they even
no,
say that there's not
yeah,
supposed to be a competitive edge between Gen 1 and Gen 2s.
yeah,
You're not going to, you at your league competitions are not going to notice a difference. And
yeah.
so,
I mean, like, okay, from performance perspective, I would say your biggest advantage, Gen 2 versus Gen 1 would be your battery.
the
And,
battery. Yeah.
technically speaking, you can get your Gen 2 battery and use it on Gen 1, you still have that advantage. The only reason is Gen 1 is using, what's it called? But Gen 2 is using a lithium battery, right? So which maintains your battery level, right? So,
Yeah. To Daniel's earlier point, if you're able to make the Gen 2 brains a competitive advantage, no one was going to beat you anyway, because you were
exactly.
going to be one of the top teams in the world regardless. It doesn't
Yeah,
matter if
and I'm
you're
pretty
programming
confident
a
that's
test.
not going to happen.
Yeah, yeah. So yeah, because my teams compete in that level. We do that kind of study, day in day out, and trying to figure out is it really worth it? It's like no, not really. Even for our top teams, right? So I mean, I have students competed, for like 3 years in a row already. This is his last year competing in IQ, right? They're in the VRC, Max IQ middle school team, right? He's our top programmer. And even when the parents ask me, should I get a Gen 2, because it seems to be a new version of this, and not really. And he has spent so much time building the library for under Robot C, and then since this is his last year doing IQ, don't even bother, right? So,
Did you have other questions, Jamie? I think we're probably going to transition here pretty soon to the next topic, but I think you said you had other questions, Jamie.
I did. My other constant problem is my kids come in with no experience at all, no engineering. I mean, maybe a little bit during one of our special areas, but like we don't have an engineering and design special. We're working on that, trying to build that up for everybody. But I didn't know if you had a good suggestion for a quick curriculum or some quick way to onload new kids to get them in on that on ramp. I know you mentioned the two different build teams. I guess last year I only had one experienced kid out of 16, and it was a really painful year. Um, we're restructuring some things this year, but if you had a suggestion for a quick way to give kids some basis for building and engineering, I would love to hear it.
Here's a quick way. And I've realized that kids learn better from other kids than they do from us adults, is jumping on YouTube. Kids just love diving in, going to the search bar, typing in VEX IQ, and then filtering it to the most recent uploads. And there are just unlimited amounts of other kids on there and some adults on there as well, providing unlimited amount of resources, build ideas and design. I mean, we're not trying to reinvent the wheel here. We can learn from each other and be inspired by other people. And so have them jump on YouTube, have them type in VEX IQ, have them filter it to the most recent uploads, and just let them get lost in that. And the more they get lost in that, the more they're going to learn and fall in love with that's the quickest way, I think. And then of course, obviously, you as the coach, networking and finding coaches that you respect who maybe know a little bit more than you and asking questions. I still ask a ton of questions. You can ask Adam and Daniel and Malhar. I'd ask them a million questions all the time and probably drive them nuts, but I'm constantly trying to learn myself because I'm not an engineer. I'm a 5th grade teacher and I didn't grow up doing this stuff either. And so I'm constantly trying to learn so that then I can then teach my students as well. I don't know if anyone has any better solutions to that, but
I
summer
have a
camps.
solution. Well, let's say when you said your students come in and they don't know what to build, what to start working on. The best place to start off is obviously with the game analysis. Like Daniel said earlier, we go through the game manual. Watch Jake and Adam's video, very very informative, and they basically pick each other's brains about any ideas and strategies they might have. And the game analysis basically creates this kind of environment for brainstorming and unique ideas that they might come up with. And how, as a coach, you can kind of utilize that and kind of guide them is by creating a priority list of parts to build first. So if you are a robot on the field and you want to score object, let's say you're the first slap shot, you want to score these discs into the scoring zone. What is the most what do you prioritize first? What do you build first, right? And the answer always is, oh, I need a shooter because there's all these discs on the field and I need to get them into the scoring zone. But the answer actually is always a drivetrain because you need to move around the field first, right? So it's prioritizing. It's prioritizing what you're building versus how many points you get. Let's say the blue tower has 20 discs total, and compared to the yellow tower, which has only 9. So the blue tower should be prioritized over the yellow, right? Unless you have some other conditions. But that's how we prioritize, and I let my kids know, hey, when they come up to me, hey, what should I work on next? They should already know within their team plan, but if they're asking for a smaller solution, then I say, what is your priority, and what is your next best step to do so? And on YouTube, like Jake said, they are amazing designs. You get to look at them, and it's those designs people are excited to show everyone, like, hey, I've created this amazing shooter. It shoots all 45 discs and scores them into the 4-point zone. But then when everyone just copies that, they might not have their priorities straight. So let's say they have a shooter, but then they don't know how to put it on a drivetrain, right? And then that's where they struggle. But on YouTube, you don't see that. You don't see how to integrate all those designs that they're making into an actual robot. That's something that the students have to figure out by themselves, right? So I would say keep your priorities straight, and then when you are feeling ambitious and a little excited or curious, go look at YouTube and try those cool designs.
And to his point, this is a perfect example. Running my summer camps right now, a lot of the kids are at the modification stage, and they are, we're going to cap the week off on Friday with a competition. I'm going to tell you right now, the teams that are going to do the best of that competition are the teams that kept it simple and used that priority list. I have a couple kids right now, after today, we have one more day of building tomorrow and the competition, who have an amazing shooter, like Malhar was talking about. And I asked them today, I was like, so how are you going to even collect the discs so that you can shoot them? And they're like, oh, yeah, good point, right? And guess what? Now you only have about an hour and a half to 2 hours tomorrow to figure that out. And so they're gonna struggle because they didn't have that priority list. And then you have these other teams who have a basic drivetrain that can move around the field. They have really basic lifts that can knock the blue dispensers over. They're going to get those automatic 20 points. They're probably just going to, for camp, plow them into the 2-point zones, and they're probably going to win on Friday or do the best because they have their priorities straight.
Yeah.
Oh, one more thing, if I can. I know my kids were kind of frustrated this year because we spent a lot of time with them designing their own robots and modifying and working things out. And I felt like that was a really valuable process for them. But it was very clear from every competition we went to that if you were going to win, you needed the identical Lipperbot that every single team in finals at Worlds had, that everybody had. And I really struggle with that. Like, do we play the game to win and copy what everybody else is doing that's very successful, or do we continue to really try to have kids come up with these ideas? So I know that's a big can of worms, but I'd love to hear other people's ideas.
Yeah, I'll add to that point, because we had Ben Lipper zoom into our camp this morning and asked him pretty much that very question. And really what it boils down to is this. First of all, he's not giving step-by-step build instructions to anybody. He's just putting ideas out there and letting kids be inspired by that, which I think is pretty cool. We're not trying to reinvent the wheel here. But then it does get to the point where it's like, what is the most efficient and effective way to score the most points that you possibly can? And by the end of the season, there are a lot of, it kind of just trims down to one or two designs that are the most effective and efficient. But if you look at all those World Finals robots or State Finals robots, even though they had an intake and catapults and the drivetrains like that, they all did have differences. And if you really want to think about it, think about the Flingbot this last year. All of those robots are just heavily modified Flingbots, right? Because the Flingbot had an intake and it had a catapult. And so, yeah, did they all look a lot alike? Sure, but they were all built. You take the inspiration from somebody else and you use your own creativity to make it your own. And the other point to that too is this year's game, I think you're going to see a wide variety of designs because there are so many, and I think they did that on purpose. There are so many different mechanisms on the field, or dispensers and different tasks that you have to complete, that I don't know if there is going to be that one design or those two designs that everybody ends up building, because there are so many. There are not enough motors. You can only use 6 motors, and I don't think you're going to be able to tackle all those objectives with one design. So I don't know if Malhar or Adam or Daniel, you want to jump into that point too.
Yeah.
Controversial topic.
It is, but I could add on some points in here. Even Ben Lippert-Bach's topic was brought up at RECF EP Summit, right? RECF is fully aware of the situation, right? But if you want to have some examples, just look at, let's say, Formula One cars, right? There are only basically 10 cars or 10 designs, right, for the Formula One cars, and 20 cars, right, competing at any given day, right? And then if you look at them from outsider, they look pretty much identical, right? And basically FIA published a reference design. This is what everybody should follow this year, and you go from there. Make your changes, and then there are certain areas you can make the changes, right? And those are the top engineers, right, in the entire world, right? Trying to focus on aerodynamics, and everything. And then you will see, basically the top team will always have the fastest car, the best car, and the design looks the same, right? Or similar. I would say similar, right? And coming back to the VEX competitions, right? Part of that, when we have talking about the same design or similar design in the season, part of that is also becomes, the issue from the game design, right? I actually had a chat with Dan Mans at VEX Worlds and also at the summit, regarding the game design. I think it is a common understanding from RECF that they want to make the game harder, right? Because last year's game, to be honest, is one of the easiest ones that they had over years, right? Rise Above, wasn't even that hard either, right? So that's why you always see maximum scores, right, all over the places. And one of the best game I actually like in VRC would be Turning Point, right? And then in Max IQ would be so far I like Remaster, right? The reason for that, especially Turning Point, right? Even at World's Final, you see different designs, from different teams, regardless. They come down to 2 or 3, and then you have catapult, you have shooter, you have flywheel, but none of them can actually dominate the game, right? Last year's even the VRC, some robots are, I don't know how many VRC coaches here there are some robots, they are actually designed as a shopping cart. They basically take the mobile goal and put it in their shopping cart, and they just basically, carry the mobile goal all over, entire game. Right, so I think part of that is RECF definitely to make the game much harder, right? And then the interesting part is, when Grant Cox was talking about they designing the game, right? They have some internal discussion is when they design the game, when they have the game, if they cannot agree within the team, within the GDC, how they're gonna attack the game, like they probably have a very good game because some people will say I'm gonna do it this way. The other people say no, I'm gonna do it the other way. The more they argue about it, actually the better the game will be. Because if you think about it, everybody just agrees, yeah, that would be the best way, and then you're gonna end up with the game, with a robot at the same, end of the year anyway, right? So that's just some insight, sharing with you
Yeah,
guys.
and to add
I don't
on,
know.
or to go back to your question, how does it affect this game? And if you are looking into a YouTube robot, is everyone going to have the same robot again this year? I would say, like everyone else said, it's very unlikely, but it may just happen. We never know. The hero bots are designed by VEX to have some missing or things that you might need to add on, a few things that you need to learn from them to improve on them, and so you can have a full season long, right? And I think Ben Lipper's robot might have had take too many boxes, maybe. That's why everyone liked that robot, and it was an easy solution. But for this year's game, it is so diverse that you might need to have a compatibility robot for all the good robots. So someone that, let's say it's an amazing robot that can collect all discs. If they drop a disc and they don't have an intake because they might not have thought of, they might have been like, hey, I'm going to collect all my 45 discs. You can be a compatibility robot and have an intake on your robot to collect that disc and go score it, right? And obviously, the end game requires both robots to perform and reach the end zone. So this game itself is designed to be more of A and B instead of just two A robots where they just score as much how many points as they can. The field is completely mirrored, and they just do the best. But in this game, there is only, I'd say, three straight shooting positions. So you have to pick who gets the two, who gets the one, and you have to kind of have a lot more strategy going into this in terms of where each robot is going to be at what second in match. So it'll be interesting to see how many compatibility robots are built.
Yeah. And speaking of the hero bot, one thing they did mention about the hero bot itself is they always have something hidden that you think is totally flawed design, but if you make some small changes, the hero bot itself can actually perform much better. So
Yeah.
I didn't do too much research on this year's hero bot yet, but I know for a fact last year some of our students actually moved the gear or reattach the motor to some other gears, and then immediately the catapult is way faster. And then they were questioning why it was set up initially. That was one of the hidden features. When RECF is designing the hero bot, they always have something like that. So look for it. I don't know what that is. This year I don't have the answer, but
Yeah, I don't either. I haven't looked at it as much. I think just everyone yelling that it is really bad. Don't touch it. Don't go near it. I haven't been excited to go take a look at it. But I'd say take a look at the features, understand how all the functions work, and then try to find the maximum potential of that feature, and then see how you can get there. It might not be a problem for every student to start off with, which is what the hero bot should be, but later on, or maybe halfway through the season, we'll figure out what exactly the hero bot had that we could have utilized.
And that's what we do. That's why we
Implementation
run
hero
our
bot is
summer camps. We have
Exactly.
them go through at our summer camps, build the hero bot, the snapshot. And with our elementary week last week, it took them pretty much the whole week to build that hero bot. And they quickly realized once they went and tested it out on the fields that it was not great. Like you would maybe intake one, maybe two discs for the entirety of the match, and that is not efficient at all. This week, middle school kids, they blazed through that hero bot yesterday. On the first day that we were building, and are completely tearing it apart. Like they're not even like keeping the drivetrain or anything. They just, as soon as they got it built, they tested it out and they realized that it was not great, and they just completely tore it down, and they are starting fresh with a brand new robot for Friday's competition. So it's always a good starting point, especially at the elementary age, to just kind of figure out how things are put together. And so that could kind of answer one of your first questions, Jamie. It's just having them go through that process, and that teaches them the different build concepts and how the pieces fit together and all that stuff. And it does teach some cool mechanisms as well. And then it's really important to go test it out and to realize this does not match the goals that we have and the strategies that we have. So now what do we need to do to either improve this Herobot or to start over from scratch to achieve our goals and achieve our strategies?
I was gonna say, fortunately, this year's Herobot is way faster to build than last year.
Yeah. But I mean, like I know last year's Herobot, because we had our first scrimmage, back in last August, right? One of our top team, top students, he grade 2, right? You never thought grade 2 can actually do VEX competitions. I got one kid who did that, and he can score 6 to 7 balls with the Herobot back in August, right? That was way before, he did any redesign, rebuild or anything, right? So a lot of time it's not the robot itself is here, right? How much effort you put in, how much thought you put in, right? But when you get a kid who will wake up, I know this part doesn't apply to everybody because that kid has everything at home, but when you got a kid wake up at 7 a.m. in the morning before all the parents, going to the basement start practicing, he's a winner, regardless of the result, right? So, okay, all right. In programming, is there different speeds in the motor? Yeah, I mean, like from 0 to 100, right? I don't know, maybe getting into a little bit more details, though. Okay, well, Joe is typing, so I may want to share something about the programming. I guess these are supposed to be the programming session, right? Lots of people think, caution tape may have some secret ingredients. We're hiding that, that allows us to, have such good performance. It's really not, right? Anything we're teaching in the club, everything we have, they're all public knowledge, right? But I want to get some, concept right for all the teachers. The first step is when you think about the programming, your number one goal is not looking for, oh, you know what, I don't know this, I don't know that, or I need to learn PID control, I need to do this, I need to have that secret, algorithm somebody has, right? I'm gonna go to the VEX forum and looking for it, right? See if it works, but it's not really the case, right? Because quick example, same student, right? That grade 2 student who did the Herobot, he scored, I think in the final in the World Championship, he ranked 16th in the entire world, right? And he has, at the beginning, I think half the season or majority of the season, he has no gyro at all. He's not using proportional control at all. His main, even at work, right? His autonomous was time-based. Think about it, time-based. As simple as you can get, right? But
What do you mean by time-based, Daniel?
Time-based basically means,
Just
your robot drive forward for like 5 seconds, 2 seconds, and then you turn right for 0.5 seconds, right? Something like that, right?
Was
For
he
sure.
using traction wheels?
I'm sorry?
Was he using traction wheels for that?
half traction, half. Oh, wait a
Yeah,
second. Half traction,
it was
half Omni,
all
right?
Omni, I think. No, it was all
What?
Omni in the beginning.
Yeah. That's right. It's all Omni.
Because yeah, what they did was if you remember last year's field, it was just like hit the wall or like just drive until you hit the wall and then have a timeout, and then they used to ride the wall like as a guide. So you don't need
Okay.
a gyro because the wall is straight. You can just yeah.
Right, exactly. There are so many techniques that you can actually use, right? Like hitting the wall, hitting the bar, reset yourself, and then, if you actually see their route, watch carefully. They hit walls like crazy, right? And that's how they did it, right? It won't give you like, if you want to win world, right? It won't do it, but it's good enough, right? Make them top, 20 teams in the entire world, right? So, but going further, and then, definitely you want to level up, and then, you can learn more about, proportional control, if you're comfortable with it. If you really want to learn a little bit more, we do have a blog which published actually last season, actually 2 seasons ago, right? Yeah, 2 seasons ago. Not even last season. It was
Yeah, too.
back in 2020 or early 2021, right? Those YouTubes are on, Caution Tips website, on our YouTube channel, right? I had so many teams coming to us saying, "Hey, Daniel, your video helped us, right? Like Tintin Robotics, right? I had a girl, and she was, and I was interviewing lots of kids, right? And one of them, he or she didn't know that I was from Caution Tape, when he was doing the interview. And then they were talking about, the programming side. I learned this from Caution Tape's website. I was like, okay, great. So, those are great techniques, right? But end of the day, it's not about the tool, right? So that's all I'm saying. So going back to the question, for the speed part, yeah, you can always set motor speed to whatever you want, right? So
I'd say if you set
so
it to 50% speed, you don't gain any more torque, like strength. Usually when you're gearing down a motor, you acquire that much torque, but you lose that speed. But in case of electronically or in code slowing down the motor, you don't get that. You only lose the speed. So it's I'd say recommended not to do that. I'd say just keep it 100. Mechanically slow it down if you need to.
yeah. So I mean, like, because when kids going to higher level, like a VRC level, right? For sure, there are so many algorithms out there. The kids are doing odometry, right? Like right now, even our VRC kids are doing that. That's no secret in the VRC work, right? And then there are, kids are doing like Pathfinder, those kind of things. Way more advanced math than what I can do, right? Already. So, but the key question is, when you develop your kids, especially at elementary level, at middle school level, it goes back to the original question we had, right? Are we, teaching them to win? Are we teaching them to learn, right? It's a fundamental question, right? Because when we teach them just simply to win, it won't last. Because at one point they're gonna give up, because they're gonna be, especially when the competition is getting harder and harder, at a higher level, at a VRC level, they're not going to be any Ben Leapfrog for them to copy, right? That's, even if it's in RECF, everybody knows, the basically the student center program, policy issue is really not an issue in the VRC. It only happens in the, well, I wouldn't say it's not an issue, but you will see much less problems in the VRC. But you're going to see much more in the VEX IQ level, right? Overcoaching issue, right? But when we teach the kids to learn, to explore, and then they can actually be better themselves. And in most cases, especially at the VRC level, you will see students are actually better than the coaches, right? The coach doesn't have to know everything. It's up to the students to actually explore. So the great coaches, the best coach, can actually coach the players better than them, because there is something they just can't do, right? But I still could be the best coach out there, right? You don't have to be the best player. That's all. Any questions? Okay. Maybe I would just talk a little bit
I
more
had,
about.
I
Yeah.
actually had a question. I had a question.
Sure.
I can't get my camera to work, but I took over a team coaching for a teacher that passed away, and we took over in the height of COVID. So that was a terrible year. Last year, I feel like was our first official year getting under our belt, and we talked to you at Worlds. We did really well last year, but we still struggle with programming. At state, our kids, all four of our teams were in the top 20, which was pretty good, but I don't feel like we know the sensors very well. Sometimes when we would plug in our gyro, the robot would go in 360-degree circles, and I felt like we didn't understand. So we end up taking sensors off and just programming with kind of like what you said, timing and
Mhm.
simplicity, and it worked for us. But we would really like to get better at sensors and more I don't know, like a better sense of how to program more effectively and efficiently. So if you have any tips for that, that would be
Okay.
great.
Okay, sure. So to use the sensors, 100%, right? If I'm picking one sensor to use in the VEX IQ competition, it will be gyro, right? Because basically, when I teach programming to the kids, sometimes I do a small game with the kids, right? Say for example, the kid is standing somewhere in the classroom, and then I tell him, hey, why don't you go walk to the door? And then the kids will, so that's an easy job. Just, walk to the door, right? Come back. Okay, now I'm gonna ask you the next thing. Close your eyes and still walk to the door. So try that again, and he's gonna, definitely bump into something, right? A wall, a table, whatever, right? Because it's the same thing happens to the robot, right? Because the robot does not have eyes, he cannot see. So it relies on the sensors to sense where the robot is, right? So using the gyro sensor will definitely be your first start. But there's one, I'm gonna get into a little bit technical here. For gyro sensor, you have to understand that there's one tricky part. There's a rotation, there's a heading. So do not mix them up. Because if you're using heading, your number goes from 0 to 360. So which could be a big problem sometimes. Because a simple math won't work properly. You know what I mean? Because it wraps around. So when you turn into 0 and suddenly your number goes to 360, it could be depends on how you write your program, it could be catastrophic, right? So make sure you do use the rotation, because rotation goes from literally a negative infinite to infinite, right? So it's basically from it could be negative 180, and then you keep turning around, you could get a negative 360 and negative 720, things like that. So make sure you do use rotation. And then if you figure that out, the first thing you need to do is make sure you have a proper a turn function, right? The way we're teaching the kids to to actually use the gyro sensor is we have this I wouldn't call it a technique, but a methodology we're teaching the kids, right? I don't know if you guys are using MyBlock or not, right? If you are, that's great, because that's a great start. You make sure your kids are using MyBlocks, right? And then you can even as a teacher, you can help them to create two MyBlocks, right? I'm not saying you're creating the MyBlocks, but you're telling them, hey, I need two MyBlocks, right? The first one would be a simple turn function, right? And turn by gyro, and then I need the robot to be able to turn 30 degrees, negative 30 degrees, right? Or 720, 360, whatever that number is, right? Do not let them to go further until that turn MyBlock is fully tested. That's the fundamental testing, right? I know Adam is works for I believe works for Salesforce or something like that. But in the engineering software development world, right? Adam, where do you work?
Yep,
Who do you work
Salesforce.
for? Yes, right? Yeah. So, one of the testing, technique is in the professional industry is called unit testing. All I'm saying is they need to do their own unit testing before they go further, right? Make sure the turn is 100%. And the most common mistake is like 100% of the mistakes you will see with every single kid is you ask them to do something, especially in the programming, is if they think they can turn right for 90 degrees, they think their job is done. It's not. Because think about this way, if you assume your turn has a couple of parameters, right? Or inputs. The first one would be rotation, your target rotation, right? The second one would be your speed, right? That's it. Two numbers. But there are a couple of scenarios, right? Let's say you can make a right turn, you can make a left turn, but what if your power is negative? Does your turn function still work? What if your robot turned for over 360 degrees? What if your robot turned for 90 and then you ask it to turn back for 90? Does it still work? See, all of them does not require you to have programming, background, like at all. It's just a simple common sense. Are you covering all of your edge cases, right? In the industry, we typically call it, the first case, that the kids are make it work. We think, okay, now, I think I got the algorithm, right? It's called happy path. But the kids will settle at happy path, and that's it. And that's where you're gonna have all the problems. And then you think your code is done, and then you're gonna work on, okay, let's create your goal straight, right? You create your goal straight, you think you do your happy path, and now you think, no, it's done, right? But when you integrate them together, your route becomes much more complicated, right? It becomes, now I need to go forward for like 5 centimeters, I need to turn right for 75 degrees, I need to go forward or I need to go backward, and suddenly just everything just blows up, right? That becomes your testing was not enough. So one of the things we always ask all of our students to do is what we call it a square test, right? Because the only 2 functions we ask them to create at the very beginning would be turn and go straight, and that's it. And then the only testing they have to go through would be the go square testing. So basically your robot goes straight for X amount of distance and then turn right for 90 degrees and then go straight and then turn right, go straight, turn right, go straight, turn right. And then if you can complete the square and returning to the same spot facing the same direction, you complete your first part. And now you can go forward and then make a left turn. Now you can go backward and make a right turn. You can go backward and making a left turn. Trust me, if your kid's robot can do that square test on 4 directions, you will be fine. I would say 90% you will be fine for your autonomous. So simple, very simple. Do not think about, all those autonomous tasks before you can, before you finish your square test. So that's it. Simple thing to do.
We have about 15 minutes left in the programming portion. Are there any other questions on programming?
I actually have one. For kids that are not necessarily starting out like from scratch, but who are, let's say, just past beginner but going on to intermediate, which sensors would you steer them to avoid?
Oh, which sensor to avoid?
V1 distance. Right. Just avoid it. Just avoid it.
Yeah, we use the most 2 common sensors we use are gyro or inertial from V2 and the color sensor, right, or optical from V2. Right? So those are the most 2, and then touch LED would be very helpful too. touch LED is a little bit advanced topic already, but if you use it properly, it could give the kids a great feedback, right? Some use case, I don't know if everybody can get the point. Is say, for example, we're using the touch LED to monitor whatever, let's say we're using the PID control, we're monitoring how off, the robot is on the current course to the target rotation, right, or target heading. If it's off by a certain amount, and then, the touch LED will turn into red. So we know whether our KP is too high, it has that zigzagging problem, those kind of things. Use the touch LED as a visual feedback, and use your sound. Sometimes, like say, if you are using color sensor trying to find the lines on the field, do some beep, right? Beep. I see the line or not. So it will be a great feedback, because lots of time when the kids are programming autonomous, it's totally blind for them, right? I program this way, I just hope it works, right? So VEX Code VR, yeah. I to be honest, I love VEX Code, VR. I don't know if Mark already left. Mark Johnston is, I think he has a series of great videos about VEX Code VR, but you have to keep in mind, VEX Code AR is more focused on computer science. So your kids will learn a lot in VEX Code VR, more leaning into real computer science programming. But your problem, you come from your VEX IQ or VRC competition, is not just about computer science. That's why it's so hard, right? That's why the actual major about robotics is called mechatronics, right? In universities, right? It's basically mechanical plus electronics, plus all your algorithms, right? So that's why that's why like Tesla, autonomous, self FSD is hard, right? Because it's everything. You have to know mechanically, about the robot. You have to know how well it's built. You also have to know your algorithm well enough, right? Because internally, when I talk to the coaches, even talk to the kids, sometimes they think programmers will think my code will solve everything. It's not, right? If you don't have a properly built robot, your code cannot do anything, right? You need to make sure your robot can actually drive straight without any code first, right? You're giving 95% of accuracy by itself already, which means, your robot is symmetrical, you don't have like one side has way more friction than the other. And then your code can solve that, little problems, you have. Otherwise, you're just asking for trouble, right? And then question regarding the motor percentage affect the distance when it travel. Not really, but unless you're traveling at 1:3 gear ratio and you're traveling at 100% speed, right? And then you could have something, but very minimal, right? You don't have to reduce this too much, but I wouldn't consider it as a factor about the percentage, it itself. But you have to also know that it's not about the distance itself, it's about the momentum, your robot is carrying. It's like you're driving a car, the simple question I ask the kids too, right? If your mom is driving the car at 15 miles per hour, you ask her, hey mom, stop. Your mom is able to stop. Your mom is driving like 100 miles per hour. I don't think any mom will, but maybe say 70 miles per hour in I-90, right? You ask her to stop the car. Can she stop the car right away? I won't. Simple physics, right? So that's what it is. The momentum your robot is carrying. Our team has always coded this one line chain of written code. They loaded one program to the brain. Not yet. Okay, Amber, very good question. Especially for VEX code, VEX code, you cannot do it with multiple files. It is definitely highly recommended if they can do multiple files, but that's not even possible right now with VEX code. Robot C can do it before, but not the case for Gen 2, right? VRC, VEX Code Pro can do it with multiple files. Pros can do it multiple files. VEX IQ so far no solution yet, but what I have heard there could be something coming up, but it could be a little bit too advanced for IQ students to handle. That's all I'm saying, right? So yeah, Adam was showing the code that the kids was doing. Definitely, instead of using multiple files, what you could consider is my blocks, right? Even though it's still one program, one file, but your code will be much more readable, right? You could create one my block called go straight. You could create one block called turn, and then assuming you have multiple runs, which means each run is defined by you start the robot does something, and then basically stop, the program stops there, and then the kids need to manually reset the robot to somewhere else and run a different program, right? So that's defined as one run, right? Sometimes you could have 2, 3, 4 runs, within your 1 minute programming skills, and then my suggestion, even though you cannot create multiple files yet, but you could create one my block called run 1. And run 1, you have your bunch of lines of code, and then you could have your run 2 with another bunch of code, and then your main program you're gonna look like from run 1 to run 2, run 3, run 4, right? It will make your code much readable. And have the kids write comments, right? Even if I'm looking at Adam's sample code, I don't see many comments over there, right? So have them to write some comments in the code. It will help them, because otherwise all they're seeing is just a bunch of numbers, right? 90% of their job they're doing is just tuning the numbers. And when you have new kids come in and then say, that's in line 10, the first thing they need to figure out what this robot is doing and which line is that, right? So, write some comments, say, for example, if your robot is doing a couple of actions before manipulating the game object, right? Write something right before your game object, right? We're doing the blue dispenser, right? I'm doing the purple dispenser. Or I'm making L turn to get around whatever a tower that is. So put a comment there that will help your kids to navigate through the code in the future, even for themselves, right? Because lots of time if they need to make a last minute change at a competition, it is not pleasant, right? To read through 30, 60 lines of code and trying to figure out which number I need to change. So.
Well, and I think what Amber, one of the parts that she was asking about, you said we used to do one long chain of written code. Does that mean that you were, you would write your code, then you'd press start, and then you would just let the robot run one continuous run for the entire minute? Is that what you're talking about? Because I think you hit on it a little bit, Daniel. But yeah, you don't have to write one long continuous code where it just works for the entire minute. You can run and do a task and then pick it up and put it back in the starting position and press your touch LED or press whatever your checkpoint and let it run a second code. I think that's what she's asking. And if that's
We did We did that last year. We ran because it was a mirror image field. We ran code on one side and then stopped it and ran the same code on the other side. So we've done that, and then we've used the touch LED to start and stop and do different things when we wanted to run it. But we were told that and it might have been a VR team or somebody else that was saying, "Oh no, you can write multiple chains and then save them on your brain that way." And I was like, "We
Well, you
can? I didn't
can.
know."
You can if you do like at the end of your first run in the
Okay.
same file at the end of your first run at the bottom. I think you have like a broadcast to there's like a I'm not
Oh,
a
I
programmer.
see.
Broadcast, and then once it hits that broadcast, then you can start a second line on the same file, same downloadable file. Then it starts your second
Okay.
one once you
Well,
press your button.
I
I mean,
see.
there's two
So
things. There's two things there. So to answer the first question directly, yes, you can have multiple programs on the same brain. You just have to choose the slot. So if you're using VEX Code IQ, up in the top next to the name of the file, there will be a number to the left. That is the slot that it'll go in on the brain when you download it to the brain. So you can have separate
Okay, that's
programs
what I was trying to
entirely.
figure. Yes. I was trying to figure that out. That's very helpful. Thank you.
Yep. And the other way, and that we're referring to here, and this is why I brought up this example. This isn't a really early example of code, like last fall, I think, but this is using the LEDs, two different touch LEDs, to be able to select which part of the program you want to run. So there are two specific runs. So the two blocks on the right, with all of the my blocks in them, one is to go and do some shooting, and the other one is just to go and hang. So they would run one, pick up, reset, and then hit the touch LED to run the next one. And those are just ran on events, and which event is broadcast is based on a state, which you can see on the left with the step.
Okay. Yeah,
and that's
I
all
think,
one file.
yeah. I think part of that, if your team is running multiple programs, that means, or even they're running the same program for multiple times, means, the program stopped and you rerun the same program, then, you can definitely, do a much better job there by, what Adam was saying, using the touch LED. That's basically what my teams are doing, all the time. What I can do actually later on is we can actually publish some blog and talking about that in a little bit more, dive in details, giving you some ideas of how to chain them together, and as well as using the event to basically trigger different actions, right? Say, for example, last year you have your run one being on this side, collecting balls, shoot balls, right? And then run two is identical, the same thing. That will be chained together. And then you could have your last action being, just go hang, right? You have to think about your use cases, right? In this case, because in some cases, or I would say 99% of the case, if it's a perfect run, all the actions would be chained together, right? You will do things like go forward, turn, go ahead, and if it goes right, and then move on to the next run, and so on and so forth, right? But in some cases, you're interrupted by, your robot is stuck somewhere, and then you have to do a manual reset. Sometimes you want a manual trigger on, you know what, I run out of time. I just want to hang, right? To at least get some points, from the hand, right? That event-based technique will help you in such way. So great question. I guess I have some action item, later on. So we will publish another blog, a video, and talking about, how to use a touch LED to, chain all the runs together.
Yeah.
Thank you. I appreciate it. We'll look for that.
I say, if I could also interject one other thing, most of the programming discussion here has been like it feels like a lot of it is entirely gauged or geared towards autonomous. Autonomous is not the only thing you can program. You can program for the controller as well. So being able to select which slot your program is in is really, really helpful for when you're programming what the controls for your controller are, So you can start to actually build up some automated macros even for specific buttons to be able to press, telling mechanisms to go to certain positions and stop with a single button press instead of holding it down and releasing and praying that you got the position correct. So there's a lot of things that you can do with that too.
Yeah, yeah. The macros are definitely, something, I wouldn't call it a secret, but something advanced teams, use all the time, right? For example, how do I find a good example? I think right above, we have a couple of them like that, right? For example, when the robot is approaching the rider and trying to grab it, what we have found out is if the robot is approaching too fast, it's gonna, basically knock down the riser and not be able to grab two of them and put on to, the third one later on. So what we end up doing is, for some of the teams, what they found out is, we just approach close enough, and then they're gonna press a macro. Basically, the robot will automatically slowly drive forward and automatically grab and lift at the same time. So that kind of action is going to be very hard to manage to do it, for the kid. But if you program that, on a button, and then, it will give the driver, some advantage, right? It really depends on, right, how good your driver is, right?
Yeah, and even the same game, there was different heights that you needed the arm to go, and they were pretty much always going to be the same heights. So being able to program a stopping point, like I hit the button and it goes to the top, hit a button, it goes to the middle. This game, maybe you want to have a button that shoots one disc and you want another button that shoots a burst of 3. So you can do things like that.
Yeah. So yeah, that's where the programming will actually help your more advanced teams, right? To start with, one thing I want to emphasize, I know, I'm to my minute, my hour, but programming skills is your key to the work, right? I don't know if that's a problem for Indiana because you guys have too many spots. Well, elementary, only have 4, and the middle school only have 8, but programming skills will be the only thing that will allow your team to actually be really advanced, or have that competitive advantage, qualifying for higher level competitions, right? So, so focus on that, and plus, that's the only thing, if you really have a coder, he or she doesn't like to build, he or she doesn't want to write notebook, programming skills is the only thing, they would love to do, right? I do have kids like that, right? And for a fact that when you have a kid only interested in programming, you're actually lucky too, right? Notebook takers are, you're also lucky too, right? If you have a kid who's really into taking notebooks, then you're aiming for Excellence Award, right? Design Award. But when you have a programmer that's really into programming, and then you're aiming for programming skills, and then you have a really well-rounded team, right? I just want to add some quick comments regarding the team size we had discussed earlier. In Caution Table, what we do is slightly different, right? Because we are not public schools, right? We run things slightly differently because we do see kids from grade 1 to grade 12 all the time, right? So we set up our system to grow the kids, right? So for any of our IQ team, to start with, they always start from like a 2-person team. The reason for that, we can test the kids, skills level, right? To see what they're interested in, and also give them the opportunity to basically try building, try programming, try engineering, notebook taking, and then once they are, going into 2nd year, 3rd year, we know what they're capable of, and we know where their heart is, right? And then, we set them up as a bigger team, right? So our top team could be easily from 3 to 6 kids, depends on what they do, right? The kid could have minimum, we have to have 2 great drivers, right? Top teams, right? And then there has to be a programmer in it. it has to be a notebook taker unit, right? If we can find one, right? And then that's how we set up our teams. So hopefully that helps for. I don't know if that's the case for your team or not, right? But that's basically how we set up. Okay, so I guess I'm up for my hours, right? For programming, and if any coaches still have more questions regarding the programming, I can type my email in the chat. I will type it right after. And I also want to say this season I posted in the WeChat, sorry, not in the Facebook group, that we actually kickstarting a student mentoring program this season. Basically, one of our, if you're a public school team, right, one of our top XIQ students or VRC students will mentor your team for the entire season. Basically, remotely for 1 hour per week. Any question they have, for XIQ team only, right? So they can help them out throughout the season. This is basically part of our community outreach program. Hopefully we want to help more teams, as much as we can. Right? So I already have quite a few signups, right? Hopefully I have enough students to cover everybody, but if not, then it's going to be some selection process. There's going to be a form. Actually, I can post that form in the chat later on as well. So yeah, that will be everything from programming side. Now all yours for building.
All right. Welcome to my workshop. No, I'm just here now with all my parts so that if you guys have any questions. To introduce myself, I am Mahar Soni. I have been doing robotics since I was in grade 8. I'm 24 now. It's given me around, I think, 10 years of experience doing VEX, FRC, and then on the later half of my student year, VEX IQ started, and then I was working part-time. And yeah, how I met Daniel was I was always competing with another club, and we would always meet in the finals, and Daniel would beat me because his game analysis is his mindset was being an IT professional, he knew how to do things and get results, whereas I was like the enthusiastic, very curious and very passionate robotics mentor slash student, and yeah, I would always get that into my kids and get them to be very, very good drivers. But then like you probably already noticed, programming is very, very important. And yeah, so any questions you guys have, let me know. I know there was a gear ratio question, so if that person is still here, I'll go ahead and I'll explain that. But other than that, take it away with any questions you guys may have. Any questions? Let me check the chat. Okay, I'll wait like 10 more seconds. Okay, so if no one has any questions, I would just like to give something to the community and maybe like give some tips and secrets that we might be using and what my students have developed over the years, and kind of now it's a given for every student because they see it in our scrimmages, in our competitions. They get to be in person to take a look at the robots, so I get to learn from them, and as well as the other students too. So the number one thing I would say is if you're starting a new team, I know some of you are looking to buy the V2 kit, and in the V2 kit there is a few things that are very, very useful. And the number one thing I would recommend to try on is the motor shaft. The motor shaft is, if you've never used it, it's basically an axle that you would want to plug into your motor or any other axle, how you use it. But the motor axle is basically something that has a divider on the axle itself, and it prevents your axle from being disconnected or disengaged after you connect it. So no matter how hard you pull on it, your motor axle will stay in there. Now, that's the number one thing I've seen on Herobots, on the basic robots that everyone builds. I've seen robot videos where there's wheels that are just like kind of canted, meaning all the robot weight is in the center and the wheels are all being forced outwards because the axles are not supported on both sides, and also the axle is coming outside the motor. So we'll definitely use that. Another thing I would say is the difference between gears and sprockets. So we do have a bunch of videos coming out from our students that explain the different uses for them. Everyone uses, I've seen them use sprockets. Sprockets are the one with the bigger teeth for drivetrains, but for a drivetrain to have a good transfer of energy or power, you would want to have you would want to use gears, because when you put two gears together, there's less slip between each tooth. But when you put two sprockets together, the chain slack that you may have, or if there's some of you fishing folk, when you have you understand what slack is. When you pull on the fishing line, there's the length of string, and whatever part is not tightened, we call that slack. And for the motor to pull on that slack, it would cause delay in your program, in your auto, and even in your driver. So that would be a big disadvantage. So I've explained that simple step through testing and trial and error to my students to make sure that they're not using just sprockets for their drivetrain. We do have a new video coming out where we're showing or showcasing using gears for the gear ratio. So someone mentioned changing the speed for the motor. In this case, we keep the motor speed 100 in the code, but for the drivetrain itself, the gearbox we call it, we change the gear ratio, and we gear it up over there. And then once the gear ratio is changed to what we want it, let's say 5 or 3 for speed, we would use sprockets to connect both wheels, the front and the back wheels. Now, what that does is, for this year's game, you might have noticed there's not much space in when you're driving the robot around. And what this allows you to do is keep the same gear ratio while changing the wheelbase of your robot. So the Omni wheels themselves, they can be closer or further apart as you choose, and all you have to change is how many chain links you're using. Whereas if you're using only gear ratios, we have to change up the entire gear ratio and figure out. The hardest thing to use with a gear ratio is figuring out the spacing and how everything can line up while having a number of gears so they spin the same way. Right. So I would recommend using gears and sprockets. And the last thing, if you haven't watched any workshop videos that we posted, I would say if you're using anything that is moving on an axle, you would want to make sure that the pieces that are rotating, their contact is very low towards the bar that is supported by it. So let's say you have a bar right here, this beam over here, and you want to plug in this yellow gear. Now, because the yellow gear is so big, there's a lot of contact going on from the gear towards the side walls, the outer rim of the beam. And how do you, or what does that actually entail? When there's more contact in a machine, there's a lot of friction, and friction is basically slowing you down. If you have different friction on both sides, or any mechanism that you want to lift, or for speed, it basically gives you a disadvantage. So friction is a big no-no, and we don't like that. So what we do for any axle that has a rotating function, we use a washer, and it's hard to show this, but washer is very, very thin little spacer, and we just use that to overcome VEX's design issue, which is they have a small little brim on any of their pieces, and we overcome that by using a washer. So when you put it in the gear, now instead of having the entire contact of the entire surface area of the gear, you now have only the washer touching the beam, right? So that is much less friction, and if you do this throughout your robot, throughout your drivetrains especially, you will have a much better drivetrain, much faster drivetrain, and much stronger mechanisms when you build. So these are the things that I would recommend kind of memorizing, and I always bring it up. Hey, are you doing that right? Or whenever my students are building, I make sure that all my coaches know this, and small trick that we use, so it makes their life easier, and it's also because VEX IQ is so limiting in terms of its engineering design integration, meaning that let's say if you were to build a car in with VEX IQ pieces, you couldn't because the pieces themselves are so limiting. So it's always hard to exactly test if the friction from the gear itself is slowing down the drivetrain, or is it something else, right? So this is something that is like a principle from the engineering field, and we're bringing it into VEX IQ. And these are things that we use, and I promise there's nothing more that we kind of keep to ourselves. So this is everything that I would recommend knowing, and maybe having a small workshop with your students and doing exactly what I did here, and pick their brains about it, ask them about what happens to a gear when you do that, or what a motor shaft can do, and some issues they might have with a robot, you can solve with these solutions. But yeah, that's all I have to say. Any questions?
Now, Harvey,
Advantages
you
and
have
disadvantages, yeah, of different tires, and also using tracks. So there are different tires in V2, and the biggest, factor you can probably know is the difference between omni wheel and traction wheel. So obviously, traction, by its name, gives you a lot of grip on the field, right? And it's a plastic field, it's a rubber traction wheel. It gives you a lot of grip, and what that basically means is when your robot wants to stop, your wheels stop. Whereas the omni wheel, when your robot wants to stop, it can stop the wheel, but because the omni wheel has omnidirectional wheels on top of it, it can move left and right, and your robot may not recognize it, right? Because what you are tracking on your robot to drive forward or turn is actually the motor encoder, or let's say the gyro degree. The only difference is that the omni wheel is moving around left to right, and you can't track that, right? So the autonomous program, and even your macros or presets might be more complicated if you use all omni, right? Whereas yeah, and last year's game, people used all four omni wheels just because the driving style was very very cramped. They were very long robots, so you had to have a difference in um, turn radius. Now, what turn radius is basically, if you have, let me show you. So turn radius is basically where your robot actually pivots. So if you have a traction wheel, it's basically like where it pivots. Your robot will, let's say if you have back traction and front omni, your robot always pivots between, if you draw a line between the traction wheels, that's where it pivots off of. So it pivots like this, right? But if you have four omnis, it's now an X on the robot, and that's your pivot right in the middle. So now your robot will pivot like this, right? It will pivot right in the middle, and it will give you more room to turn around in. So it depends on the game. This year's game is pretty small, so omnis do look great, but it is a lot of movement and a lot of maybe resetting on the field. So you might want to use traction. That is something that it has advantages and disadvantages, and you guys have to figure that out, or the students have to figure that out by themselves, and basically go one way or another. They're both right. One is more driver focused, the omni wheels, where they give you very good maneuverability, where you can move around the field very quick and agile, whereas the traction is very precise in autonomous and other scenarios. What other wheel is there? There is a super traction wheel. It is not very useful because when you put a lot of weight onto it, the wheel itself is more like a balloon. So it will just compress itself, and now you only have two outer rims touching the ground. So not much traction there, unless there's other use cases that I'm not aware of. But I think that's it for tires. Best practice, so best practice is to use track wheels as drive wheels. I would say you have to figure out the combination of uses. The Flingbot or the Clawbot robots from last year, they always have four traction wheels, and they only work is because the traction wheels are all close together, so they can turn. But if you think about it, if you have four tractions, does the hero actually pick up discs? I'll tell us next. But if you have four tractions, it's very, very tough to turn because now each wheel has to skip on itself to turn. Therefore, you'd want to use omni wheels either front or back. Now, again, like I said, if it's omni in the front, traction in the back, your robot will be pivoting from the back. But if it's traction in the front, omni in the back, your robot will be pivoting in the front like this, right? So whereas like your head of the robot will be won't change as much compared to the traction of the back, your head will change a lot, the distance and the length of your robot. So that's the combination of drive wheels that you have to choose from. And I would say give the combinations to your students and let them test it out by driving and also programming. It'll be a while before they actually code and find out the answer, and what, like, that Omni wheels are really a pain to deal with. But that's something you might have to kind of give them a further notice of, like, hey, what about later on when you do programming? Is this going to be accurate enough or not? Right. Next question is, does the Herobot actually pick up discs? The Herobot does pick up discs. I don't have one right now. The students have taken it apart, but what it's a conveyor belt system where it has an intake using those mini traction wheels, and the disc goes up and it flips into the robot. It's more of a conveyor system if you think about an industry machine where there's a bunch of conveyors running. It is a sort of machine like that, and then the mechanism to shoot it out is more of a compression system. I don't know if I know Adam and Jake would have more info on that, on how it works, but I have not gone into detail on that robot yet.
Yeah, it works essentially the same way, just with kind of like the intakes from last year, very similar. So it pulls it in on the bottom and then flips it up upside down on the top, and then the shooter, like it moves along the conveyor belt with the rubber bands. Then the shooter is more of a, it's basically the same shooter, I'm pretty sure. It's just the compression with the 2x2s. But
Exactly,
it'll pick
yeah.
up, like, it's really only effective with one disc at a time, like consistently. I've seen kids get two, but you have to be perfect if you're going to get more than one.
Yeah. So like Daniel said, two Omni, two traction will work best 90% of the time. That is true. And unless you're going for an H drive, which is an Omni in the middle, you can omnidirection, you can move any direction you want, whenever you want. Just Google search that. There's some very, very cool videos that can kind of excite the students on to building that. Next question is, are there any parts that you strongly recommend we purchase that aren't part of the standard VEX robot kit, specifically for building those bigger robots that can be more effective in competition? So yeah, like Daniel's already saying in chat, the gears. So there are a few types of gears that you get in the V1 kit. There's so there's teeth on each gear, and that's how they're named. So this one is I think 8 tooth. No, see, I don't even remember now, because as a club itself, we call them 1 gears because they're 12, yeah, because they're multiples of 12. So this one is 12, whereas the next one will be 24, the one after will be 36, and then there will be a 48, and then a 60, right? So these three, the blue ones, are the ones you get in the V1 kit. They are very useful. It's nothing that gives you an advantage of, but like I said, when you're using gears for drivetrain, the gear ratio really matters, because some students might not be used to the fast speed, and they might not be able to effectively or over a long period of time be reliable and drive that speed, like some robots on YouTube that we've seen. So you might want to gear it down a little. The best case for that would be to buy the 24 and 48 tooth gears. These gears don't come in the V1 kit. You have to buy them separately. They do come in the V2 kit, I think, right? Pretty sure they do. But this is definitely a recommended purchase. The next one would be the motor shafts. So like I explained already, the motor shafts, the one with the divider, they come in this small little bin. It is very expensive. I think it's like $16. I'm not sure in USD, but they come with these dividers in there to prevent it from coming out from the motor, and that's what they call motor shafts. There's also cap shafts, meaning they have a cap piece on. Don't know if you can see that, guys, but there's a cap on top of the axle. And what that does is, if you drop the axle through a piece, it just doesn't fall through, right? So now, let's say if you have your drivetrain and you have the exact length of the shaft that you need, you can have this on the outside, and you don't have to cut any axles. right? So very, very useful. I would say another piece, yes, avoid plastic shafts, chain sprockets. Yes, there may be some sizes that you might not have for the sprockets, but sprockets are, I think, compared to gears, it's an 80-20. Gears are used 80% of the time. What else? Yeah, avoid plastic at all costs, because at all costs, if you use plastic shafts, first of all, your robot may be less reliable because a plastic shaft can bend inside the beam itself or even inside the motor, and you may not know. We've had multiple cases of that in the early years where we use plastic shafts and one of our motors or the wheels are not turning 100%, and you never know until you actually take it out. So that is something that is a big no-no in any machine world. You know, if it's not reliable, do not use it. Otherwise, there are consequences, right? So the also the motor shafts and the cap shafts. If you don't want to buy them, you can take a test run with the plastic shafts that come in the V1 kit. The only difference is they are plastic. So if you do like the use of them, if the students like the use of them, you can use them. And also the plastic shafts you can't cut because they're not metal, whereas the metal motor shafts and cap shafts, you can actually cut them to whatever size you want. What else? Yeah, the last thing I would recommend is the bin, or not bin, but cap shafts. So any part that you see, or you probably built the fields, all the coaches and teachers, cap shafts are very, very hard to use. They're hard to put in. They hurt your fingers. Your fingers are numb after building the field each year, and there's a reason for that, right? They are structurally they're much better. Each connector piece that VEX makes is built on compression, and it's used through compression, and the cap shafts are just better. So if I would say any any part of the robot that uses a lot of or is underweight and is gonna break if you bend it in other directions, I would just use a cap shaft and forget about it. So a connector is much easier to break through and release, whereas a cap shaft will actually stay in there and actually be harder to take apart later on. But that's one of the things I tell my kids is the harder it is to take apart, the better and more sound of a chassis or frame you've actually built. What else? We just upgrade to all metal shafts. Yup, you learned the hard way. Yup. I think we all did. And then they released these very expensive ones. Can you speak to different motor sharing mechanism, differentials, and passive mechanisms? Okay, so this is fishing for some hints on the game this year. If you have already done game analysis on this year's game, there are a lot of things to do on. Please show the item again. Which item? Cap shafts? Or sorry, cap connectors. Can someone link cap connectors? Or Daniel, if you can link cap connectors, motor shafts, what else? And cap shafts. Cap connectors are pretty inexpensive. You can get, I think, 100 for a few bucks. Speaking on what I was saying before, the game this year is a lot of tasks, and you can do all those tasks pretty simple. They're pretty easy to do if you just use one motor and do them. But the issue is you only have a six motor limit. So in order to do all those functions, you would need 7 to 8 motors. So that's the tricky part for this year's game design, where you have to integrate other mechanisms into a one motor mechanism, which is what Adam is kind of saying, is a motor sharing mechanism where one motor has a task to do two things. Or he thinks that you say differential. Yeah, differentials as well. And passive mechanisms are where you are not using any motors. It's let's say if you have an arm on the robot and you have a rubber band, let's say stored energy on the robot where it flings another arm when you are lifting something. So it's a passive mechanism. It's passive activated, and it just saves you a motor on that. So any ideas for that? I would say the best way to do that is if you are starting off, or if your students are starting off building a robot or the first robot, even the second version of their robot, I would say to limit them on 5 motors, because if they can build a robot that is good enough for the first or second version and use only 5 motors, it'll be very easy for them to move on to the version 3 or 4 of the robot, because they'll have that 1 extra motor left. I think that's all I would say on that. Differentials is a very complicated topic on motor sharing, and I would look at a few VEX like VRC videos on differentials. They are very good at explaining it. I don't have a CAD on me to explain, but I would if I could. They have very good animations on showing them. In terms of passive mechanisms, I'd say stored energy. That's the only way to do passive mechanisms. What else? Let me get this. The only example I have of a motor sharing mechanism is, where's the camera? Okay, this little swerve drive that I'm trying to build for fun. It basically powers the wheel with one motor and also turns the module with another motor. So that's a very complicated example of motor sharing. It's just having one motor do two tasks at the same time, and that multiplies to all 4 sides. Okay, any other questions? Oh, also, I forgot this part. If you've played, I'm losing my voice. If you played the pitching in game, triangular beams are the best structural support piece. That's, I'm gonna get water. Give me a sec. Yeah, so like I was saying, the triangular piece, very, very good. Definitely save those from your pitching and field. Yeah, that's a few months in the making. Just can't find time to finish a swerve drive.
Any other questions for, it could be, obviously we're still on mechanics, but since we have less than 30 minutes left, any questions at all for Daniel, Jake, or Malhar, Adam, or for anyone really, anything that you might need help with before starting your season, whatever we can do to answer any questions. This is your time. And I appreciate Daniel putting in that link to the form if you're interested in getting a mentor to help out with your team. That's a very great offer that you don't want to pass up. So make sure you take advantage of that link that he put in there. And then also I take the time to check out Caution Tape and Jake Simons. And I know there's probably others that have been involved in creating the IQ Masters curriculum. I included those links when I promoted this event, but I can't stress enough, there's so much great content in those links. So maybe we'll post it again just to make sure you have direct access to it. There's so much good content there. So make sure you use that throughout your season as well. And maybe one of you, Malhar, Daniel, Jake, could put a link to the Facebook group, the IQ Masters Facebook group. I think that would be a great resource if they've not connected in that platform yet.
One thing I'll add is it is for last season, so pitching in, but anyone looking to start programming and getting to the next step is it's the best thing to look at.
And it looks like Malhar Adam did add a question. How would you go about ordering or designing and building typically? Do you let the kids decide or direct them through questions or another way?
Order of design and build typically. The best way I'll put that is we make a priority list with the students. So basically what needs to be built first. And then what we do is we have an end checkpoint, which for us is the first scrimmage, which is in the end of August. Now, if you have 2 months to build your first version of your robot, you want to split it up into weeks and what you're going to be building each week, and just follow the design process. You know, you have ideas, you want to brainstorm, you look at online robot videos. I don't think the triangles are available for purchase. They are kind of the souvenirs kept from each team and club, because VEX loves to use them, and we keep them around for robot usage. They can be 3D printed, but you can't use 3D printed parts for your VEX IQ robot. So Joe, since you're asking, the best place to find them is probably in a Hexbug kit. So Hexbug is also a VEX partner. I think it's a VEX partner or something like that, but they use VEX pieces to build their Hexbug kits. And what we do is just keep an eye out on Costco or any Walmart and take a look at the Hexbug kits that they sell. I think there's one that's $50 with like over 1,300 pieces, and it's an amazing kit to get. It's where we got our string, it's where we got triangular pieces, it's where we got a bunch of stuff I can show you here. So there's this piece that we've never used before. There's a bar. Which kit has red wedges? The red wedges. Ramps, you mean like the blue ramps that we use for Rise Above? Are you talking about these, Adam?
Yeah.
Uh,
I forget which one of your teams had them, but one of your teams had the red ramps, and I've been trying to figure
yeah.
out where they are.
Let me get back to you on that. Yeah. So
Sure.
we have a lot of Hexbug kits, and I think our parents are just on auto mode where if there's a sale, they just publish it and everyone buys it.
Nice.
I'm sure Joe will appreciate this. This is a from VRC. It's a Lazy Susan, and this is what I've built with it. Hold on, let's get a camera. Okay, so a Lazy Susan is basically this little black disc that is holding another disc, and it allows you to build this cool claw. Because for our summer camp or summer coding camp, we had an Armbot build, and we were trying to build this for our coaches.
Yeah, you should be able to find those in the planetary gear pack, I think.
Yeah. But VEX does hide a lot of their cool pieces in the Hexbug kits. Like they are in the planetary pack, but there's different sizes that you may not have seen that are in the Hexbug kits. Yeah, all Hexbook parts are IQ legal. Yeah, 99%. Just to make sure, I would go through a legal parts list, and even if it's updated, I know VEX is going through a legal parts list update for the VRC parts. Again, we're not saying this is a pay-to-win sport. We're saying these are very nice to have parts. You can still win without them. The green part we saw as a spinner. A green part. Not sure if we have that. I will pull it up. Yeah, the number one piece to acquire for building purpose will be the triangle, then the motor shaft, and then cap connectors.
Do you guys ever happen to use the like a lot of the Hexbug kits that are out there are not motorized, so they have like the hand cranks? Do you use those on prototypes?
The hand cranks, like this thing. Oh, this thing.
Yep.
We don't really use them on prototypes, but our Z team used this for their ratchet mechanism. They had a catapult which was adjustable with a ratchet to basically adjust the tension on the rubber bands, and they just used this for tuning, and they took this to the field.
And so we just towards the end of the year we ran into those, and that was my first thought was like, hey, especially for things that are hard to turn that you don't necessarily want to put a motor on yet, they could be really useful for.
Yeah, but the first thing I grab is a sprocket. It's the exact same thing, but a little easier on the skin.
Fair.
Another cool, really cool piece that is introduced this year through the Hexploit kits and the V2 kit is the plastic sheet. Let me see if I can get it. Okay, we don't have them, but yeah, the plastic sheet is very useful because it can help guide in like no other beam can. So we found that useful as well. I feel like we're scaring away all the new coaches with all these new parts that they have to buy.
All right, last call for any other questions. I mean, this has been, I can't speak on for everyone's behalf, but I feel like it's been very, very helpful. And just want to say thank you to the coaches, Caution Tape Robotics and Jake Simons and Adam Gray. Thank you so much for your willingness to answer all the questions and provide all of the useful information. Excited to see, as we're getting back in the swing of things post-COVID, getting a lot more teams up and running again. Can you cut or put holes in the plastic sheet?
No, you cannot. The only thing you can modify still is the metal axle.
And there's a lot of links in the chat, so make sure you grab any of those links that you might need before we sign off. And we recorded this and we'll post it on our website, so we'll have access to it. So if you need to come back and refer to it at any time, it'll be on the robot resource page at techpointyouth.org.
Yep. Also, if you want to join the IQ Masters Facebook group, we can continue the questions over there, and all three of us answer any questions when we can.
Awesome. Thank you so much. I agree, Amber. This is why I love robotics too. It's competitive, but very collaborative. We're all on the same team.
Exactly. Yeah. In all throughout my years of FRC of robotics, I learned gracious professionalism, meaning doesn't matter how hard you're fighting against the team, if they need a battery that's charged and you don't, they're gonna give it to you. Right? If you need a cable, if you need any help, they're gonna get provided to you, and then the next minute they're gonna be on the field against you. You know.
Right.
So.
Absolutely. Okay, well, hopefully you all feel like you've got more people in your corner and more resources, and you know where to reach out if you need help or any questions. And hope you all have an amazing season, and looking forward to seeing all your teams, hopefully all of them at state this year.